understand it. So to tackle this problem really requires some way to capture and share that sort of attacker's perspective knowledge and understanding of these sorts of things we're talking about, what sort of perspectives and approaches an attacker would take, what sort of things are vulnerable within the software, not just a vulnerability like within this specific version of Microsoft Word has a vulnerability, CVE, but what is the thing that building your own software you may do to make it vulnerable to these sorts of things. So to start, we wanted to basically introduce a couple of resources that are available for these types of people who are building and deploying this sort of software. The first one of these is called KPEC, and you heard Tom when he was rambling through said KPEC at one point. KPEC is the Common Attack Pattern Enumeration and Classification. This is a resource developed by an international community. It's led by MITRE and it's hosted by MITRE, but it has hundreds of different people around the world involved in doing it. Basically, it's a collection of attack patterns, so common approaches to attacking software. So it has a schema that describes things like a detailed attack execution flow, what an attacker does, how they do it, what sort of skill and knowledge is required, what sort of resources are required, which sort of weaknesses in software do these attack patterns focus on and target. The other side of the equation is another resource called CWE, or the Common Weakness Enumeration. Again, it's an international community led by MITRE and hosted by MITRE, but involving even a much broader footprint of organizations than KPEC is. Both of these are available for free. They're available right now at the URLs that are on the screen there, and they're giving me the slides. KPEC currently holds between 300 and 400 attack patterns descriptions, and the CWE currently has over 800 weaknesses defined. So there's a lot of great resource knowledge, this basic fundamental yin-yang set of the attacker and the weakness perspective that form a great resource for people who are looking to build this sort of software, deploy this kind of thing, to look at the kinds of things they should be thinking about, to understand how an attacker would view their software and what sort of things they want to make sure are not there, what sort of security features and engineering they need to put in place to try and actually prevent this stuff. The different patterns that we've talked about here today, these 9 different patterns, in the next release of KPEC, which will go out in the next couple weeks here. We were trying to get it done before this conference, but we weren't able to get it out there. But you saw during a few of the slides actually referenced these patterns will be in the next version, so there will be a full description of these. But once again, this is just 9 added on top of like 320 that are there already. The reason it's higher than 320 is there's also categories and views and things that help organize these within classification taxonomy so you can understand how they're related to each other. So beyond that, one of the things that KPEC and CWE both share is they don't just describe the problem. They actually strive to give prescriptive guidance. Here are the things you can do to make sure that your software is not the one being talked up here next year by not just us, but anybody else. So what are the things that you can actually do? So we wanted to leave you with at least a couple of slides here, a few detailed elements of prescriptive guidance to avoid the kinds of attacks we're talking about today, to help secure these sorts of application frameworks and social networks a little bit. This is by no means an exhaustive list, but these things are some pretty good things that should be involved. So starting out with some guidance that are specific to this talk. So the most egregious things, the most egregious attacks that Tom was talking about really are ones where you can not only spoof or manipulate the content of messaging with things like the cyberbullying of changing an image and that kind of stuff, but really it's that ability to do phishing, the ability to actually do in-URI type exploit injection, to do malware propagation through those links. Those are the really bad things. And there's been a good first step. We talked about earlier that there's been some movement from the time we proposed this talk and then from the time we built the first deck. About a month ago, Facebook released a feature they call Secure Stream Publishing, which does framework-side validation of user-side, client-side generated messaging for the URIs. So these sorts of messages that go back and forth, when Tom showed you the image with the little fields in the lower right that are they accept those kind of link fields, all of those link fields now, if an application developer uses this opt-in feature, on the Facebook framework side, it will actually validate that the URIs coming through in those links are within the application-owned domain. So it doesn't link off to somewhere else. So that doesn't solve all problems, but that's a pretty huge step to actually making sure this stuff doesn't go off. Now, one of the things to look out for is sometimes that might break your actual application, because maybe your application goes to links that aren't inside your domain. And one of the first kind of reactions to many different developers may be, well, let's just build a general redirection. Well, now you just broke the whole feature. So the feature's there. One of the key things is it really hasn't been publicized yet all that much. We strongly encourage the people from Facebook. We're not dinging them because they're working towards the right thing, but we strongly encourage them to make sure that all the application developers out there are aware of this feature and encourage them strongly start using this as a first step towards doing this. As of today, Yoville, which is the application we'll be showing you, and all the other Zynga games have actually fully implemented this feature. So all of their communications with the framework application framework are no longer susceptible to this sort of link manipulation, at least. The framework still has the ability to do image manipulation and the text manipulation of message, although that's a little bit limited to cyberbullying because Facebook does destructive transcoding all images, so there really shouldn't be a way to inject anything through that. At least there's not anything known right now, but like anything, that's only today. Tomorrow somebody will figure out some way to do that. But this really is a really great first step, but the key is it has to be used, and right now it's not being used widely, so we strongly encourage its use. Beyond that, there are some different approaches that could actually fully secure that sort of message traffic to allow the client side can't control or manipulate or generate any of that sort of message content. One of the ways of doing this is using application-generated messages with whitelists. So rather than have the client hand the content to Facebook, there's the possibility the client can say, within any application, there's typically not a valid use where the user can generate a magic message of their own. It's usually from a set of known messages. So they could actually put a request in to Facebook saying, what we want is message 24. Facebook communicate with the application vendor saying, hey, they wanted 24. And then the application vendor hands down the content. And now you know that it hasn't been mucked with. It's actually official content, and then Facebook or the framework could publish it. Like with anything, there are some downsides to this. That can involve a significant amount of traffic between the application framework like Facebook and the application vendors. So that's the reason it's not being done today, and that's a trade-off that they have decided to make. It may be a valid decision today. Going forward with some of the security issues, it may reach the point where that isn't the case, and there may be some application frameworks other than Facebook where maybe they're dealing with less number of apps, and so they can actually deal with that sort of traffic. So this is a much more secure approach, but there are some business reasons why it may or may not be the right decision today. So beyond that sort of specific to the attacks we talked about, there's also some general guidance if you're doing these sort of applications against application frameworks, specifically within a social networking context, that are just good rules of thumb. First of all, if you're a framework vendor, you're a framework operator, you really want to establish and enforce, is the key here, some clear rules for application behavior. So what kind of applications are valid? So all of these things we talked about of protecting the messaging traffic are only going to protect you if you're dealing with a valid, non-malicious app. But the reality is you can actually publish to many of these things a malicious app. And it can have completely validated that the content is coming from you, but if you're doing bad things like phishing, scamming, spamming, all these sorts of things, you're still making the user vulnerable. The reality is many of the frameworks, including Facebook, have policies defined for these things, but there's not a whole lot of really proactive enforcement of some of those rules. I will say that just this week, Facebook took a pretty significant step, and they discovered one of their developers had a repeated pattern of this sort of behavior, and rather than just banning an app, they banned that developer from ever publishing anything on Facebook again. So that's a great step on that kind of thing, and just it's better if it's done in a consistent and wide fashion, which it isn't today. Another thing is to enable granular approach to friends and trust. So right now within these social networks like Facebook, there's only one level of friends. You're a friend or you're not. And that implies all of the possible interpretations of what that trust means. So it would be actually much more effective from a security context if you can have multiple different kinds of friends or different levels of trust. This is a friend that I have on a personal nature. This is a friend I have in a business nature. This is a friend I have playing Yoville. And that way, if something comes to you from a friend within a certain zone of trust, maybe you're going to put a lot less trust with somebody who's in your Yoville friend list than somebody you've known for 20 years. Right now, you can't distinguish that. When it comes in, you're going to have to recognize their name and understand it. Some of us who only have a couple hundred friends, maybe that's okay. Some people have a couple thousand friends. That's just not going to be possible, really. So better granularity is going to actually lend to supporting better security structures going forward as well. Instituting a mechanism to convey the trustability of applications. So Facebook has a basic capability of that right now where a given application on the application page, users can go and say, I like this application. That's really the extent of the trustability right now. The reality is most people who use Facebook and they use apps, they're typically going to click that like because they think it's a cool application, it does something fun. They're not clicking like because of its security. So that really is not all that great of something, but having mechanisms like some of the e-commerce sites like Amazon and some of those things have right now where there's a little bit more than just but you can actually make some security qualifications. It'd be a good idea to work some of that in so that when a user actually sees an application that they want to use or they see traffic from that application from one of their friends, they can make some trust decisions. Part of that also is education of the users to actually understand some of these things. Next one is employing clear and visible measures to expose message spoofing. So right now, Facebook, and once again, is the example, when a message comes through from an application, the lower left, it has a little icon, a little thing that indicates that's generated at the framework level for that application, what application it is. So the user who's spoofing a message currently can't spoof that, although they can do near homographic attacks. So instead of Yoville, maybe they could do Yo-Ville, and you're not going to notice. But maybe a little bit better structure so that a user, when they glance at a message, will know that it's official or not. Maybe structuring a header, things like that. Because right now it's pretty easy to spoof content, and only an educated user or somebody who's really looking out for it is going to notice that it's not there. It's not there. Part of that, once again, is user education. SafeBook recently added a page on safety. Facebook safety is describing some of the stuff. You really have to be proactive and go find that. So finding ways to actually make this stuff more evident to the general user who may not be security savvy is a very good idea. Then lastly, the last one here is establishing proactive processes of vetting apps that actually get into the framework. So are they malicious or not? So this is the kind of thing that Apple gets dinged for sometimes on how restrictive they are for what goes into the application store. But they actually do think about, now they don't test anything, but if they know things are malicious, they might keep them out. Right now, most of the social networking frameworks are fairly open game. Unless you've been banned by name, like this one Pancake who was done this week, typically you can throw an application in there and there's not really a proactive vetting process to know that you're a valid application just building a fun little game, or you're somebody who's building some sort of a phishing page, phishing application, or anything like that, or any kind of malicious software download. I mean, it could be that the Flash client that's actually downloading for the application itself is full of malware. And right now it's pretty easy for anybody to actually install one of those into the Facebook framework and actually have people start using it. So we would strongly recommend a much more proactive approach to that. So I think that's all that we had for the guidance. So last little bit is, anybody want to join a group here of the Rafflecopter Appreciation Society? You can trust us. It's perfectly safe. You can go and join it, and we won't screw with you at all. So if anybody has any questions, we're happy to take questions on any of this stuff. Any of the detailed questions for specific mitigation stuff we'll probably leave to Chris, because he can speak from the actual vendor's perspective that actually built them in. Any of the questions on some of the higher level research patterns, stuff like that, we're happy to take those either in the room or offline anytime. So thank you.